Empirical formula is the simplest whole number ratio that a formula can have. A really good example of an empirical formula is 1 carbon, 2 hydrogens, and an oxygen, or CH2O. This is the formula for formaldehyde, which might be a chemical that you've heard of before. It's used to preserve all sorts of dead things. A molecular formula is a formula of a covalent compound, and usually it's the multiple of an empirical formula. So sometimes I'll put the word multiple next to the word molecular so we don't forget that. So if you take the compound formaldehyde and you multiply it by a factor of 6, you get 6 carbons, 12 hydrogens, and 6 oxygens, which is the formula for a chemical that we have to live, which is glucose. It's kind of strange that these two formulas both have all of the same elements in them, but this one's just 6 times more elements in it than the formaldehyde is. So very different things. Formaldehyde would kill you, and glucose you have to live. Some molecular formulas can be reduced, which just means you can take the formula and divide it by some factor that's a whole number. So we could take the glucose formula and divide it by 3 and get C2H4O2. There's a silly little poem that you can jot down to help you remember empirical formula. So the first line of the poem is percent to grams, then grams to moles, our favorite unit to change everything into in chemistry, divide by least, and multiply until whole. Like I said, it's not a great poem, but these will help you remember the steps that you need to take when doing empirical formula problems. You'll always do steps 1, 2, and 3, but you won't always need to do number 4. I'll show you some examples when you do need to use number 4. Let's try the first problem on your notes. It says, for example, a compound is 66% barium and 34% chlorine. You need to figure out what the empirical formula of this compound is. So we're going to follow our first step. Change grams to moles. And this is probably the easiest step of the whole thing. If you have 66% barium, it's just 66 grams of barium. If you have 34% chlorine, it is 34 grams of chlorine. Barium's molar mass is 137.33 grams. It's best not to round your molar masses when doing empirical formula problems because we want the most accurate answer possible. And chlorine's about 35.453 grams. So we want grams to cancel out. We want to end up in moles. We're going to put 1 mole of barium on the top here and 1 mole of chlorine. Take a second and pause the video so that you can complete your calculations. Okay, I'm going to go out to about 3 decimal places. So for barium, I got 0.481 moles. And this is in moles. I don't have space to write that all down, but you can go ahead and write that down. For chlorine, I got 0.959 This might be slightly different depending on the periodic table that you're using. The next step we're going to do is divide by least. So all you have to do for this is look at your two numbers and decide which one of them is smaller. And in this case it's barium. So I'm going to divide both of these by 0.481 because that's the smallest of the two numbers. Obviously for barium you don't even need to plug that into your calculator, it's just going to be 1 because you're dividing a number by itself. And for chlorine you're going to get a number that's really close to 2. It's like 1.99, so we're going to go ahead and call that 2. Now what does this mean? These numbers are really close to whole numbers anyway, so you don't need to do the multiply until whole step at all. You can just throw that out for this one. Your barium though, you'll have 1 barium according to our calculations. This comes out to be 1. And you'll have 2 chlorine atoms. So the answer to the problem is BaCl2. Let's try another example. This time we have 3 elements. So go ahead and set up your calculations to change grams to moles. Okay, I found the molar masses for all of my elements. So I'm just going to put 1 mole on top for each. Now you want to go ahead and do your calculations. You should do these to 3 decimal places. So you can pause the video here and do your calculations. Now determine which of these numbers is the smallest. You're going to divide all of the numbers by that one. So aluminum's number is 0.470, so we'll divide everything by that. This one is 2.997, but that's close enough to 3. This one's close enough to 9. It's 8.99 essentially. Okay, so you're going to end up with 1 aluminum, 3 nitrogens, and 9 oxygens. And this would be an okay formula, but it's not the best one because you've never seen a compound really written like this. So think about what might have 3 nitrogens and 9 oxygens in it that's written a little bit better than this. If you came up with aluminum nitrate, you're correct. This is the point that I want you to eventually get to, where you can figure out what the real formula of the compound might be. Let's try another example. This time you're already given your amounts in grams instead of percentages. So it's no different, you just don't have to do the first step. So you have manganese, nitrogen, and oxygen. We're going to change all of these from grams to moles. So pause the video right here and set up your 3 grids. Okay, your grid should look like this. Maybe you've already done your calculations. Those need to go out to 3 decimal places. Okay, now we have our 3 numbers and we need to divide by least. So the smallest number here is going to be the number for manganese. So divide each of these numbers by the smallest. Okay, so your formula will be Mn into O6, or to rearrange this, it's manganese nitrate and it would be manganese 2 nitrate. Okay, take out your worksheet and we're going to do number 2 on the front page, and this will be an example of how to use the last step in the poem, multiply until whole. So go ahead and set up your 3 grids, pause the video right here, and restart it when you're ready to do some calculations. Okay, now we have our 3 numbers, our numbers of moles, and so you need to find the smallest number and divide by least. Sodium and chromium's number are almost exactly the same, but chromium is slightly smaller, so let's go ahead and divide everything by that. Basically, we're going to get 1 for sodium as well, or close enough to 1. Here's a little bit of a change from what we've done in the past. On oxygen, you get 3.49, which is really close to 3.5. 3.5. If you have 3.5, you can't really round that number all the way up to 4. It's too far away. So what we're going to do is multiply all of these numbers by a factor to make 3.5 a whole number. So if you think about this, 3.5 is 3.5. If you want to multiply a half by a number to make it a whole, you multiply by 2, and that's exactly what we're going to do for each of these. So 3.5 times 2 is 7. 1 times 2 is 2, and 1 times 2 is 2. So your formula here will be Na2 Cr2O7, which is sodium dichromate. Here's a helpful chart to figure out what number you should multiply by. So I've just included the decimal number, the fraction, and the factor you should multiply your number by to make it a whole number. If you have something like 0.49, that's really close to 0.5, so you can just multiply all of your elements by 2 and you'll end up with whole numbers. This is a little bit tricky, but you're probably not going to have anything that is weirder than what's on this chart. So play around with it. If you come up with a formula that's impossible, you know that it's time to go back a few steps and figure out what you might have done wrong.